Hi class, we're just going to go over lesson 3, part A. So this was an exploration, so I actually wanted you to come to most of the conclusions by yourself. So watch this after you've actually done the investigation. So please don't watch this before. This is just a quick summary video. You should have already finished this exploration by yourself, but I'm going to go walk through it with you. I'm just going to draw this line out here. Okay, so interior angles. So what you're going to be doing in this investigation is exploring the interior angles of a polygon. Interior angles are the angles formed inside each of the vertices of the vertex of a polygon. So these are 3 vertices, the ones that are in here. The angle that I have outlined in red is angle ABC. We always look for the one in the middle. The letter in the middle often indicates which angle we're looking for. Right? So then in this situation, we're looking for this angle right here. Okay? So what we're trying to figure out is, this is the problem. How can you determine the sum of the interior angles of an angle of 20 gon, which means that it has 20 sides, right? So what we're going to do is we're going to start off by doing a little bit of an investigation. So what you're going to do, or what you should have already done, is draw a quadrilateral. So I already drew one over here. And draw as many overlapping diagonals as you can inside of the figure. So I already did this for us. Don't draw it like this. So this is overlapping because you have these two lines intersecting here. So don't do that. Same thing here. You have like these lines intersecting. We don't want any of that. So what we mean by non-overlapping, we mean something like this. So we have this diagonal, right? So we split this into basically 2 triangles, right? Anything else we try to do here won't really work, so we're just going to leave that as is. Over here, we're going to split this up into triangles too. So I'm going to start at, usually if you just start at one vertex and then go here, we have one triangle here. And then if you make one across, you have one triangle there. And then you have one triangle here, right? You have 1, 2, 3, 4 triangles, right? So it says calculate all the sum of the angles in all triangles. So let's do, I'll put this one in purple, right? You're going to do this for all of your shapes. Like I said, I'm not going to do this for all of the shapes. I'm just going to do the 2 that I've already drawn in, right, to show you how to get them. And then you can go and do the rest by yourself. So I'm just going to draw in this lovely hexagon here too, right? So I'm going to do 2 for the purple one and for the red one, and then you can try doing the rest by yourself. I'm going to give you the answers, right? But it's your responsibility to have tried doing them all by yourself. Use a separate piece of paper. So it says, calculate the sum of angles of all the triangles. So let's do triangle 1. This is going to be 1, 2, 3. I know that inside this triangle, it's going to be 180 degrees. So triangle 1 equals 180 degrees. Triangle 2, still a triangle, still going to be 180 degrees, 180 degrees. Therefore, the sum inside all of it, therefore, sum inside the rectangle, right, is going to be, of all the triangles, is going to be triangle 1 plus triangle 2, right, which is going to equal 180 plus 180, which is going to give me 360. That means that the sum of all of those angles of the triangles inside here is going to equal 360. So let's try to do the same thing with the hexagon. So with the hexagon, I have 1, 2, 3, 4 triangles. So I know sum of the angle of all triangles is going to equal the sum of triangle 1 plus triangle 2 plus triangle 3 plus triangle 4. And I know that the sum of triangle 1 is 180. I know that the sum of triangle 2 is also 180. 180 plus 180, right? So 4 times 180 is going to be 720. Okay? So what you're going to do, and what you should have already done, is for part B and C, you're going to repeat this with each one of these polygons. So each one of these polygons, you're going to have repeated the same steps of taking the shape and dividing it into a bunch of triangles, right? And then finding the sum of the triangles. So I'm just going to go here and put in my answers. Not going to draw them out for you, but you should have drawn these out. So we have a triangle. The number of triangles that are inside a triangle is obviously just 1, right? And the sum of all of its interior angles is always going to be 180. Then we have a quadrilateral. Go back here. Our quadrilateral could be broken into 2 triangles. So I know the number of triangles inside is going to be 2. If I want to know the sum of the interior angles, I know it's 180 plus 180, which gave me 360. Right? And you're going to do the same thing for the pentagon. We already did the hexagon as well. So inside the hexagon, we had 1, 2, 3, 4 triangles. Right? We found out that we had to do 1, 2, 3, 4 times 180, so that gave us 720. I'm just going to go fill in the rest. So for a pentagon, when I drew it out, there was 3 triangles. When I did the math, I found that it was 540 degrees. For a heptagon, which has 7 sides, there was 5 triangles, and it added up to 900 degrees, right? And then for an octagon, it added up to, there were 6 triangles in there, and it added up to 180 degrees. Okay, and so on and so forth. So an n-gon is just a polygon with any n number of sides. So when we were looking for a 20-gon, which meant that it had 20 sides, right? So we're going to write how many triangles. So let's make a comparison between our triangle, so the number of sides that it has, and the number of triangles that exist inside of it. So it has 3 sides and 1 triangle, right? Now, let's move on to our quadrilateral. It had 4 sides and 2 triangles. Okay. 5 had 5 sides and 3 triangles. So we're starting to see a trend here, right? Every time this goes up by 1, this seems to go up by 2. We can also say that for every number of triangles, if we subtract 2, we can get the number of or any number of sides, if we subtract 2, we can get the number of triangles. See if that works. So if we did 3 minus 2, it would give us 1. If we did 4 minus 2, it would give us 2. If we did 5 minus 2, it would give us 3. If we did 6 minus 2, it would give us 4, and so on and so forth. So it's safe for us to say that if we had n minus 2, it would give us the number of triangles that exist. Once I found the number of triangles, I just needed to multiply it by the number of the sum of the interior angles of that triangle. And the sum of interior angles of a triangle is always going to be 180. So whatever I did here, I did 2 times 180, gave me 360. 1 times 180 gave me 180. 3 times 180 gave me 540, right? So even when I was doing this here, when I was doing this up here, there was 4 triangles in here, so I did 180 plus 180 plus 180 plus 180, when I could have just done 4 times 180, right? So what I can say now is that if I want to find out what the interior angles is going to equal, I just need to take the number of triangles that exist in there, which I represented by this equation. So let's do this like this. Let's derive this equation. Number of triangles multiplied by 180 degrees. degrees, right? And I know that the number of triangles is just n minus 2, which is the sides minus 2, times 180 degrees. So that is my formula for finding the sides or the sum of interior angles of any polygon. Okay? So let's graph the sum of the sides and interior angles. Let's just go in and do that. So I'm just going to use, I have the same chart open up on my computer. So I'm just going to use that. So I'm going to go in and graph them. So I know if I have, and here I'm just going to label my diagram. So this is going to be number of sides, right? And this right here is going to equal, the bottom one is always the independent variable, which is the, sorry, that shouldn't be number of sides. Number of sides, this thing was changing. So this is going to be number of sides. Number of sides, and then this one is the sum of interior angles. Right, so we're going to do that. We're going to find the sum of the interior angles. So let's just go and plot that in. So I know if my first one is number of sides starts at 3, which is a triangle, I'm going to go up to 180. So 180 is about here. If I have 4 sides, which is a quadrilateral, it's going to go up to 360. So 360 is here. 5 sides, I'm going to go up to 540, which is here. 6 goes up to 720, which was here. 7 went up to 900, so it's in between 960 and 980. And 8 went up to 1080, right? So my graph's going to look something like that. If you look at this and you remember what we learned literally last week, right? What relationship do you see? It is a straight linear relationship. Linear relationship. So it says, it's explain whether you would join the points. Would you join the points? No, because the reason you wouldn't join the points is because you can't have 0.85 of a side. It's not continuous, right? So because it's not continuous. Okay, so write the equation of the line. What's the slope? What's the y-intercept? So if I was to just go down, right, by the same logic, I went down 1, 2, 3, 4. 1, 2, 3, 4 over, right? There's no y-intercept. There, it would be, if I was going to do this, it would probably keep going until the bottom. So let's just find the slope. Let's find the slope first. So I'm going to do this over here on the other side. So let's find the slope. So slope is going to equal 2. I'm going to take 2 points on my graph. So I'm going to take 1 and 180 because I like those numbers. And I'm going to take 2 and 360 because I like those numbers and they were the easiest ones, right? So let's do this. 360 minus 180 over 2 minus 1. 360 minus 180, it gives me 180 divided by 2 minus 1 is just 1. So my slope is 180, right? Now I'm just going to use my slope point method. So I'm going to do y minus y1 equals m, x minus x1. You could also just plug this into y equals mx plus b, doesn't matter which way you do it. So y minus, I'm just going to use 180 equals 180 x minus 1 because I don't want to, I'm lazy. So y equals y minus 180. I'm going to move it to the other side. It's going to make plus 180. I'm just going to distribute this in as well. So 180x minus 180 plus 180, right? So y is going to equal 180x. Negative 180 plus 180 is going to be 0. It's going to give me 0, right? So then I'm just going to have y is equal to 180x, right? So there is no y-intercept. It's going to be 0 because that makes sense. If we have 0 sides, we have 0 entry, right? Um, or like 0 sides means I have 0 interior angle, so that makes sense, right? So it says determine the sum of interior angles of any 20 gone using your equation from part H. So let's go up here. We're not going to use our equation from 1H. We're just going to use our equation from, so X here represents the number of sides, or sorry, represents the, yeah, the number of triangles in there, right? So we're going to go in, we're going to say, all right, 180 times, oh, I made a mistake. Sorry, y'all, I made a mistake. This is in 3. That makes sense. I made a mistake. It's not 180, it's 3. 3 180 and then 4 360. That makes more sense. Oops. Sorry, y'all. And then 4 minus 3, right? Oh, it still worked out. So you still have 180, which is our slope, but our this point changes. Um, because x should be representing number of sides. Sorry, I made a mistake. So give me x1, and this is why you have to be careful. So I had y minus, I'll use the 180 equals m x. So my m was still 180. Oops. My m was still 180. 180. X minus 3, right? This is a 3, 180. Y minus 180 equals 180x. Let's do 180 times 3, which is going to be 540, right? I'm going to bring that 180 to the other side by adding it on both sides. So 180, negative 180 plus 180 is just going to be 540, right? So, sorry, it's supposed to be 0. So negative 540 plus 180. So y is equal to 180x. Let's do that. Negative 540 plus 180 is going to give me negative 360, right? So my y-intercept is going to be at negative 360. So my y equals 180x minus 360 degrees, right? So let's use this equation. So y equals 180, x is going to be 20, which is the number of sides, minus 360 equals 180 times 20 minus 360 is going to give me 320, 240, right? So 3,240 is that's what's going to give me, right? So what is the formula for the sum of interior angles of any polygon? We can write this one of two ways. We can write this sum equals, and this is what we've already done, n minus 2, so the number of sides minus 2, minus 360, times 180, which is what we've been doing. Or we can write it as sum equals 180 n minus 360. And if you think about it, and I'm just going to show you really quickly here, and I'll erase it so that it doesn't get messy. If you think about it, if we did n minus 2, and we use the distributive property, and we distributed this 180 in, that makes sense. We have 180 n minus 360. It is the same thing. Same thing of finding the same equation. Okay, they're just one's an expanded form, one's not. All right, so that's a summary of our lesson from lesson 3. I apologize for the mistake over here. Please just ignore that.